everyone, I'm Peppy and this video is an introduction to servo motors. This video is perfect for anyone who already has a basic understanding of Arduino and code. Servo motors are great for building robotic arms, claws, or any project that requires movement. They are also often a great starting point because they offer great precision without a complex setup. They are also very light and portable and can be paired with any other inputs like a button or a dial. In this video, we will learn how to, first, pick the right servo motors for your project, second, how to make the servo motor work using Arduino, and third, some applications of servo motors. There are many different servo motors out there and all of them are built slightly differently. Let's check out some of the most common ones. First, we have those with plastic versus metal gears. These small blue ones, called SG90, are very common. If you deassemble them, you can see that they have a plastic shaft and plastic gears, as well as a small electrical motor. Then there are these black ones called MG90S. They are the same size as the blue ones, but if you deassemble them, you can see that they have the same electrical motor, but they have a metal shaft and metal gears. This means that the black motors have more strength and longevity compared to the blue ones, making them more ideal for slightly heavier loads in robotics. Then you have these larger servo motors called MG995. Again, if you deassemble them, you can see that they have the largest metal gears and electrical motors out of the three, and they are the strongest compared to the two we just saw. Here's a size comparison between all three motors. Sometimes the motor might also be labeled with a particular weight. For instance, this one has a label of 20 kg. This means that it has a torque or rotational strength of 20 kg per cm. In simpler terms, this motor can support and lift a 20 kg load 1 cm away from the shaft. But if you slowly move away from the shaft, the load that it can support decreases proportionately. At 2 cm away from the shaft, it can support 20 divided by 2 equals 10 kg of load. At 3 cm away from the shaft, it can support 20 divided by 3 equals 6.7 kg of load. The torque rating is important in deciding which motor to use for your projects. If you are creating a heavy-duty project, for instance, a powerful robotic arm or prosthetic, it would be best to use a motor with greater torque. Another factor in deciding which servo motor to get is to consider whether you need a servo motor that spins only 180 degrees or 360 degrees. The 360-degree servo motors are also known as continuous servo motors. They might look exactly the same, but make sure you select the correct servo when you're purchasing it online. Most servo motors spin 180 degrees. I'll show you how the 180 degrees and continuous servo motors work differently later on in the video. Now, let's try to make these servo motors spin. You'll need an Arduino Uno, some prototyping wires, a servo motor, and a USB-B to laptop wire. Each servo motor has 3 wires and they typically have the same colors. The black wire is connected to the ground pin of the Arduino. The red wire is connected to the 5-volt pin of the Arduino. And the yellow wire is the signal wire of the motor. In this example, we are going to connect it to pin 3, but you can connect it to any of these digital pins of the Arduino. This signal wire basically tells the motor how to rotate. Here's a clear wiring diagram, and you can find it in the description below. Let's start with the code. We will first learn how to code the 180-degree servo motor. I'm using the MG995 servo as an example, but this code applies to all 180-degree servo motors. First, make sure you have Arduino installed by going to this link and download the Arduino app that is compatible with your device. The link is also in the description below. Once you've downloaded it, open the Arduino app. it should look like this. Let's start coding. First, include the servo library by typing include servo.h. Then create a servo object that we are calling servo1. This allows us to tell the servo what to do. Then we tell the Arduino which pin is connected to the signal wire of the servo motor. So in your void setup, type in servo1.attach parenthesis 3. Then we will set the servo motor to the specific position that we want. Let's first reset it to 0 degrees angle. So in your void loop, type in servo1.right parenthesis 0. Plug in your Arduino into the laptop. A new port should show up as Arduino Uno. Select that and then click Upload. Let's see where the shaft moves to. Alright, so if that is 0 degree, let's change the position to, let's say, 180 degrees, and then click Upload. You can see that the servo motor's position changed accordingly. In an earlier part of the video, I mentioned that the 180 degrees and continuous servo motors work differently. Unlike the 180 degree servo, you can control the speed and direction, but not the position of the continuous servo motor. Let's try to code this continuous servo motor. Disconnect your previous 180 degree servo and replace it with your continuous one. Both motors have the same colored wires, which connect to the same pins on the Arduino. Now, upload the same exact code to this continuous servo. Notice that the servo keeps spinning in an anti-clockwise direction, continuously and at a fast pace. Now, let's adjust the number here. Instead of 180, let's change it to 50 and upload the code again. Notice that the servo is now spinning in an opposite direction and at a slower pace. Let's try to change this one last time. I'm gonna put 90 here and upload the code again. And see how the servo just stops spinning? Now, try putting in different numbers in this parenthesis by yourself. What do you think is the relationship between all the different numbers that we have put in and the movements of the continuous servo motor? You can pause the video to think about it. The number in the bracket actually refers to the speed of the continuous servo. It can be anywhere between 0 and 180. 0 is the full speed in the clockwise direction, 90 causes the servo to stop moving, and 180 is the full speed in the anti-clockwise direction. You can find all the code in the video description below. There are so many creative ways you can use these servo motors in your own robotics projects. For starters, you can use any input to trigger the servo motors. You can use buttons, dials, also known as potentiometers, to control your servo motors. You can create this claw out of a servo motor. You can also create a simple cyborg hand using just one servo motor. Servo motors are also used in robotic arms, like this one that I made with my friend Yulia. The possibilities are truly endless with these servo motors, and I strongly encourage you to use them in your next project. Leave a comment below if you have any questions, and I'll see you in the next video. Bye!